TCS cooling. The TCS cooling approach is based on the fact that the TCS heaters employ radiant heat rather than conduction to heat the melt, and as such the heating elements are not in contact with the barrel. This creates a gap between TCS and the barrel. The TCS cooling system pulls air through that gap to remove the heat and exhaust it where desired. To facilitate airflow, cooling channels are cut into the TCS sections, and cooling rings are added to both ends of a TCS system to both allow ambient air in and to exhaust the hot air out. The cooled TCS system then consists of the TCS sections, the cooling rings just referenced, ducting, and a blower. It is important to note that the blower is configured to pull the air rather than push it. Pulling the air through the system allows the hot exhaust air to be directed as desired. These images show cold air being pulled in through the cooling ring, over the hot barrel, through the cooling channels, and then out through a second cooling ring, being pulled by the blower and exhausted where desired. Some companies retain the heat in their facility, particularly during the cold months, but most exhaust it out of the facility to improve worker condition or reduce air conditioning load, particularly in controlled environments such as clean rooms. Cooling can be activated by machine controls and programming, and when this is done, each zone is typically controlled separately with its own blower. Blowers can also be set up to be manually activated, which is typical when the cooling system is used for rapid cool down, for material changes, or maintenance. When designing for rapid cool down, the targeted rate of cool down must be considered. The rate of cool down will vary with both airflow and the size of the surface area being cooled, or the barrel size. Rex Materials provides a spreadsheet to estimate the rate of cooling. Just fill in the light blue cells to generate a plot of the cool down rate as a function of barrel temperature. The actual rate will vary due to several factors including material type and purge, but the plot provides a good baseline. There are 3 levels of cooling defined for any single length of connected TCS sections. There's minimum, which has a single blower and a single outlet. Moderate, which also has a single blower but pulls air from 2 ports. And maximum, which consists of 2 blowers pulling from 2 ports. An optional design approach offered with TCS is called Design for Future Cooling. This option allows a system to be designed with the correct configuration so rapid cool down can be added later if desired, but without the immediate added cost of the blower and support hardware. It is very important to note that rapid cool down feature cannot be added to an existing system that was not designed for future cooling. Systems designed for future cooling have cooling channels added to the TCS sections, and blank cooling rings added to each end of the system or system breaks. The blank cooling rings are there both to secure space for regular ported cooling rings if they are added later, and to seal the ends of the system, as the cooling channels on the TCS sections now leave the interior of the system exposed, which creates heat loss. Notice that the blank cooling rings do not have ports for airflow. So, a system designed for future cooling will have cooling channels in the TCS section and blank cooling rings. If you wish to add rapid cool down feature later, simply remove the blank cooling rings, add the blower hardware, install ported cooling rings, and add a blower. The blower can now be activated to pull air through the system to cool the barrel for material changes or maintenance. The blower specifications are as follows and can be found on our website. Thank you for your time. Please contact your TCS representative with any questions.